Okay, so today's lesson is direct and inverse proportions. And the learning objective of this lesson is for you to recognize and use direct and inverse proportions. Okay, so imagine you are saving up for a new Nintendo Switch by doing chores around the house, and each core is worth 50 $15. So if you have done only one core, you will obviously save $15. If you double the number of the cores, then you also will save the double amount of money. $15 times 2 is $30. And if you triple the number of cores you did, the amount of money you will save is triple too. $15 times 3 is $45. And this would apply to any number of cores. So if you've done 24 cores, 1 times 24 is 24. You'll need to multiply the money amount by 24, so $15 times 24 is $360. This relationship will apply to any starting and finishing number of cores done. So if you start from 2 cores and multiply it by 12, that means 24 cores. Then you need to multiply the money amount by 12 too. So you will save $360. We can also do this in reverse. So if we went from 24 cores down to 3 cores, it means divided by 8. Then the money amount would save is divided by 8 too, which equals to $45. When two things related in this way, we say they are directly proportional. So for this one, we could say the number of cores done is directly proportional to the amount of money saved. This also applied the other way around. The amount of money saved is directly proportional to the number of cores done. We can conclude that if two quantities are in direct proportion, then when one is multiplied or divided by a number, so is the other. If two things are directly proportional, then when you graph them, they always produce the same sort of shape. So if we make a graph of the number of cores done against the amount of money saved, well, if you didn't do any course, that means zero money saved. So there would be a point at 0.0, aka the origin. Then when for every extra course you will save $15. So for one core that would save $15. Two cores that would be $30. Three cores $45. And every time you would add $15. And it would form a lovely straight line like this. So whenever two things are directly proportional, the graph of them form a straight line that goes through the origin, that is 0.0. If we use algebra to represent the number of cores and amount of money, for example, the number of cores done is going to be C, and the amount of money saved is going to be M. Then we could write that M is directly proportional to C. The symbol that I've written here could be read as proportional to. So this says M is proportional to C. For this particular graph, we actually know is equation, it would be M equals to 15C. Since to get the amount of money saved, we multiply the number of cores by 15. The this number 15 here is known as the constant of proportionality. So whenever two things are directly related, there's always a constant that you multiply one of them by to get the other one. It won't always be 15, of course, it just depends on the question. If you don't know the constant of proportionality for one of the questions, we usually use the letter K to represent it. Okay, so here is one example of direct proportional. A is directly proportional to B. When A equals to 8, B equals to 3. And we could be asked to work out an equation that connects A and B. And to answer this question, we read the statement A is directly proportional to B. So we could write like this. We write this down mathematically using that symbol from before. A is proportional to B. Now, if A is directly proportional to B, there must be some constant number that we multiply B by to get A. And we're going to call that number K. So we say that A equals K multiplied B. Our goal in this question is to try and work out the value of K. And the next thing to do is substitute. Substitute in the values given in the question. We know that when A equals to 18, B equals to 3. So if we replace A with 18 and B with 3, we end up with 18 equals 3K. And we can solve this to find K by dividing both sides by 3. We've now found the value of K. K is equal to 6. The question asks us to write down an equation connecting A and B. We wrote down that A was equal to KB, but now we know the value of K. So we're going to write that out once more, but replace the K with a 6. So A equals 6B. This is the equation that connects A and B. So we finish this question. Okay, so we have the second question is to find the value of A when B equals to 50. We know from before that A is directly proportional to B, and we already worked out an equation that connects A and B, that is A equals to 6B. So we only need to substitute the given value, that is B equals to 50. And we've got A equals to 6 times 50. So A equals to 300. Imagine you open hotspot for your group of friends. If only 2 friends uses the data, they can enjoy high-speed internet because the data consumption is low. However, as more friends start using the data, the speed of the internet decreases for each person. This is because the total amount of data being consumed increases, leading to a reduction in the available data per person, which slows down the speed. Here was 2 friends connecting to your hotspot, and the internet speed will be 100 Mbps. Now, let's imagine the number of friends connected got doubled to 4. If you're connected to more friends, the internet speed will actually go down. In fact, if we double the number of friends, the speed will need to be half. So if we have 100 Mbps, we get 50 Mbps. If we do this again, let's double the number of friends from 4 to 8. Well, we would need to halve the speed, so we have 50 Mbps to get 25 Mbps. So if we continue to double the number of friends, we'll continue to halve the amount of speed. But what if we want to know how long it would take with 5 friends? This is a bit trickier. We can spot a pattern if we look at the ones we've worked out already. When we had 2 friends, it made 100 Mbps. And if you do 2 times 100, you get 200. When we had 4 friends, it made 50 Mbps. And if you do 4 times 50, you also get 200. When we had 8 friends, it made 25 Mbps. And 8 times 25 is also 200. So when things are related in this way, they will always multiply to give some constant number. So we know we've got 5 friends and we need to multiply it by something to get 200. Well, 5 times 40 is 200. So 5 friends would actually make 40 Mbps. When things are related in this way, where they multiply to give a constant number every time we say they're inversely proportional to each other. So we could say the number of friends connected is inversely proportional to the internet speed. And that applies the other way around as well. The internet speed is inversely proportional to the number of friends connected. We can conclude that if two quantities are in inverse proportion, then when one quantity increases at the same rate as the other quantity decreases, their product is constant. Now, if you draw a graph of this, it looks different to when we had directly proportional. So let's draw a graph of this. When you have a really low number of friends, like 2 friends, the internet speed is very high. And then if you double the number of friends to 4 friends, the internet speed become half. And then every time you connected a new friend, the internet speed decreases. But by a decreasing amount, every friend that connected to you has less of an impact on overall internet speed. So if we join up these crosses, they actually make a curve that looks like this. This curve is a reciprocal curve and it will never touch either of the axes. When two quantities are in inverse proportion, the graph of this relationship is a reciprocal graph. If we use algebra to describe the relationship, here the number of friends is going to be n, and the internet speed will be s. So we could have s is proportional to its reciprocal, 1 per n. Just like when we did directly proportional to, we can replace that proportional symbol with some constant k. So s is equal to k times 1 over n. If you did k times 1 per n, you would just get k over n or k per n. So we end up with S is equal to K per N. So here is an example of inverse proportional. It says A is inversely proportional to B. When A equals to 16, B equals to 3. So we need to work out an equation that connects A and B. So this time, since they're inversely proportional, we're going to write the A is proportional to 1 per B, which allows us to write down that A is equal to K over B, where K is some constant that we need to find. Next, we substitute in the values. So A is 16 and B is 3, so we have 16 is equal K over 3. Now we solve this to find the value of K. We multiply both sides by 3. If you multiply the left by 3, we've got 48. And K per 3 times 3 is K. Now we go back to this step here and write this out one more time, but replace the K with 48. So A is equal to 48 over B. Okay, so the second question is to find the value of A when B is equals to 12. We already know that A is inversely proportional to B, which means A is proportional to 1 per B. Okay, and from before, we already worked out the equation that connects A and B, which is A equals to 48 over B. And we just need to substitute with given and already known value. That is B equals to 12, so we've got A equals to 48 per 12. 48 divided by 12 is 4, so we've got A equals to 4. Okay, so the second topic of today's lesson is recurring decimals. And the learning objective of this lesson is to convert recurring decimals to fractions. So fractions can written in two kinds of decimals. First is terminating decimals and recurring decimals. Terminating decimals are the exact decimal equivalent of a fraction. For example, 3 per 4, we can write it in decimals from is to be 0.75. In their simplest form, the denominators only has 2 or 5 as factors. So for the fractions to be written in terminating decimals, the denominators only has 2 or 5 as factors. For example, the fractions 28 per 35, if we simplify it, it would be 4 per 5. Okay, you can see the denominators only has 5. So we can write it in terminating decimals, which is 0.8. For recurring decimals, they are decimal equivalent of a fraction with a set of recurring digits. So the digits get repeated over and over again. For example, 5 out of 9, 5 per 9 equals to 0.55. 5, 5, and it would be continue with no end. Dot notation is used to indicate which digits recur. For example, 0.23 with the dots at the upper of 2 and 3. That means the 2 and 3 digits will get replied again and again. So 0.23 with the dot equals to 0.23232323, and it will continue with no end. And second example is 1.234 with just the 3 and 4 has the dot. So it means only 3 and 4 get replied again and again. So the result is 1.234343434, and it will continue with no end. Okay, so here is one example. We asked to change 0.123 to a fraction. Please notice that we have dots in digit 1 and digit 3, but it doesn't mean just the digit 1 and 3 get replied, but it means that the digit 1 until 3 got replied. So we let x to be 0.123, 123, 123, and it will be continue with no end. The digit 1 until 3 got replied, got recur. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And because there are 3 digits got recur or got reply again and again, we need to multiply x by 1,000, I mean. So we've got 1,000 x equals to 123.123.123, and we need to subtract the value of x from the value of 1,000x. So 1,000x minus x is 999x, and 123.123.123 minus 0.123.123 is 123. So to find x, we divided both sides by 999. So we've got x equals to 123 over 999, and if we choose to simplify them, we've got 41 per 333.